So this is for our period 3 teacher. This is this is where you're going to start, and then there's another video for the self-check activity that comes right after that. But this activity is really, it's very important, but it's also very straightforward. So we're going to deal with objective, and I'm just kind of showing you how I would teach it. I described this in the other video as well, but I think one of the easiest ways for you to kind of think about how you want to teach it, and you put your own spin on it, you put your own style into it. But I'll just show you how I would do it, and it'll give you some of the things to emphasize. But you do not have to copy me. You know, be your own teacher, however you want to do it. So we're going to deal with 2 objectives on this one here. Our objective number 4, we're going to use dot plots to compare distributions of a quantitative variable across groups. So one variable, but we want to see how it applies to different groups. We're going to pay special attention to center and spread. And we're going to look at constructing accurate graphical displays of data. So we have 3 dot plots here. They display the distributions of daily high temperatures for the month of February 2006 in 3 cities: Lincoln, Nebraska, San Luis Obispo, and Sedona, Arizona. So I might actually stop right here. And I actually think the next question asks, no, we're not going to do that. I want to ask, what is the variable and what are the observational units? So I want people to think about that. And so I give them some time to think about it. You might want to use a magic goal. You might want to take a volunteer. It's entirely up to you. But remind students that each dot represents an observational unit, because the initial tendency to look at this is say, oh, well, the observational units are the 3 cities. But that's not the observational unit. The 3 cities are 3 groupings that we're doing, but each one of these is a separate dot plot. So, so the variable for each of these is February high temperature. But what does each dot represent? Each dot represents an observational unit. And if you count the dots, you're going to find out that on each one of those, there's 28 of them, because there are 28 days in the month of February. So really what we're looking at here is 3 separate groupings of data. So I'm going to write this for you. You can put this on the board if you want, but I would have, if I was making a table here, I'd have February 1, 2, 3, 4, dot, 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 you know, all the way down to 28. And those are my rows. And then my columns are, my column is temperature. And that is my variable. That varies from day to day. I could have another thing for each day. What would it be? What would be another variable? Humidity. Or I could have another variable, sunrise, time of sunrise. Right? But each of these variables is describing a particular day. And what I would have is I would have 3 of these tables, one for Lincoln, Nebraska, one for San Luis Obispo, and one for Sedona. So I'm comparing 3 separate groupings. I'm comparing 3 separate tables by using these dot plots. So I would try and get people to understand that the observational units, each dot is an observational unit, and that is describing a day. And one way you might do it is you can ask somebody to count how many dots are there for each one. When they come up with 28, then I think they're going to be able to see that the observational units are each day in February. So it says, which city tended to have the highest temperatures that month. So I'm looking at the display, and I want to see, I'm kind of looking, tended to means kind of on average. So on average, which of these cities had the highest temperatures? Just see if I get me out of the way here a little bit more. And again, you might want to use a magic bowl, or let people look at it for a minute. Don't rush, but let people look at it. And it seems pretty clear to me that the highest average temperatures were in San Luis Obispo. I mean, yeah, highest average temperatures in San Luis Obispo. You can just see it's farther up the scale. The lowest average temperatures, I would say, were with Lincoln, Nebraska, because none of the other cities have anything below like 48. And Lincoln, Nebraska is really quite a few days that were rather chilly. And then the next slide is which city had the most consistency in its temperatures that month. So I'm looking at spread for consistency. And it seems like Sedona, I mean, all their temperatures in the month of February were between like 48 and 68. San Luis Obispo between 51 but they went all the way up almost to 90. And of course, Lincoln, Nebraska, they had like a 12-degree day and then a 74-degree day. So that's the much larger spread, much more consistent, much less consistency, more volatility. So the most consistent would be if you lived in a city that, say, every day for 28 days just had 40 degrees. I mean, you can see that's like super consistent. That's no variability at all. Doesn't rarely happens, but that's what we're talking about. So we're looking at these dot plots to try and recognize center and spread. So again, it just repeats it here. Tendency, and again, like drive this word in, because when you see the word tendency, you're looking for the center of the distribution. When you see the word consistency, you're looking for the spread or the variability. That's going to be a big word, variability, in the distribution. Okay, and then it's the self-check activity, which is a different video.